Alright, so let's talk about adding and subtracting polynomials. At the beginning of the year, we started with a unit on equations, and we talked about combining like terms together. And like terms are just terms that are the same. So they both have x's, or they both have y's, or even if just numbers, just whole numbers like 1 and 2. We can always combine our like terms together. Now, we can't ever put together terms that aren't the same because they're not like. Now, when we're talking about polynomials, poly, first of all, means many, and nomial means number. So polynomial in its essence means many numbers. Now, it breaks down from there into a few different types of polynomials that we're going to be talking about specifically. And these are the three that we're going to look at. And again, we're looking for like terms in each of these. So we have the first type, which is called monomial. And a monomial is a one term. So this is, again, one term. Basically, you're going to see only one term from the polynomial. So here we have negative 8x, xy, 4x squared. Those are all monomials because there's only one term we're looking at. To kind of understand that, let's move on to binomials. Binomials means that we're looking for two terms. Bi means two, like bicycle. Here we have two terms, so you're going to see like 2x and a negative 1. Those are two separate terms. Or xy squared and a negative 1x. Again, two different terms that aren't the same. Third one, we have 3x squared minus 4x. Again, even though those both have x's in them, they're not like terms. They have to be identical for them to be the same. So a binomial is when we have two terms. Now the third type we're going to look at is called a trinomial. And tri, of course, means three. So this is a three-term polynomial specifically. So like in the first one, we have an xy, negative 4x squared, and a plus 1. That's three separate terms. Second one, 3x plus 2y minus 8. Again, three separate terms. And the last one still is three separate terms. And they're not the same, so therefore we don't combine them. And we're going to get into a little bit more, and let's look at what that means to combine like terms now. If I were to give you this problem, 4x minus 5 plus 3x plus 6, we want to simplify the expression by combining our like terms. So what you're going to notice here is we have two separate terms, two separate binomials, 4x minus 5 and 3x plus 6. Now, when I did that, I underlined the x's. That's because those are like terms. They go together. So I'm going to rewrite them where they're side by side. That's 4x plus 3x. Now, also like terms, like I said, can be just the whole numbers, like here, minus 5 plus 6. So let's bring that down. Minus 5 plus 6. So basically, I'm going to put these two terms together, and I'm going to put these two terms together to simplify. So 4x plus 3x would give me a 7x, and negative 5 plus 6 would give me a positive 1. So this term simplified would be just 7x plus 1. And that's it for our answer here. All right, let's check out this one where we have a little bit more working with some exponents too. So here we have a binomial, x squared plus y squared, minus another binomial, 4x squared plus 3y squared. Now, the thing to keep in mind here, the last one I was just adding. Adding doesn't really matter, but subtraction definitely does. And I didn't point this out in the last one, but this one, notice the parentheses here, and this negative that's standing out front of it. That's technically a negative 1. And because we have a negative in front of the parenthesis, that's a distribution property. That means I distribute to that second parenthesis. So really, let's start this by rewriting this expression as x squared plus y squared. And then I'm going to distribute that negative. So this is subtracting the 4x squared and subtracting 3y squared. Again, that's because I'm multiplying a negative 1 times the positive 3y squared. From here, I can combine my terms together. I have an x squared term and a negative 4x squared term. Remember, this is technically a 1x. So let's write that together. 1x squared minus 4x squared. And then our second terms go together, plus y squared minus 3y squared. Again, that's a 1. So I'm going to put plus 1y squared minus 3y squared. And let's combine them together. Let's get our final answer here. So when we combine our x squareds together, that's 1x squared minus 4x squared. Forget about the exponents, only focus on that number. That's 1 minus 4, which is a negative 3. And the x squared term just comes down as it is. Don't even worry about the exponents. We're just combining our numbers together essentially. In the second expression, I have a plus 1y squared minus 3y squared. And again, just looking at those numbers, that's really a 1 minus 3. So 1 minus 3 would be a negative 2. And then again, I'm just going to bring that term down, y squared. So this term simplified, this polynomial expression simplified, becomes negative 3x squared minus 2y squared. All right, let's try this one where we get a little bit more complicated. Some more terms we're adding. This is a trinomial plus another trinomial. Again, that's 3 terms plus another 3 terms. And remember, we're looking for like terms only. Now, again, this is in parentheses, and this is really a plus 1 outside the parentheses. It doesn't matter, though, because anything times a 1 is itself. So I'm not going to distribute the positive here just because it doesn't matter if I distribute it. But let's look at our like terms. I'm going to start with this 3x squared. So scanning across, I want you to notice the next time I come to an x squared is right here at that 2x squared. So let's start by writing those terms together. 3x squared plus another 2x squared. Okay. Second term's negative 4xy. So again, scanning across it, I have another xy here, and that's a 1xy. So let's write those together. That's negative 4xy plus 1xy. And then finally, our last term in this first trinomial, we have a 3y squared. And then here I have another negative y squared. And again, that's a 1. So let's write plus 3y squared minus 1y squared. So essentially, I'm going to combine all the terms that I can together. So these two, and then finally these two. And again, when I do that, I'm just looking at those numbers. 3x squared plus 2x squared is really 3 plus 2. Which is going to leave me with a 5, and x squared comes down because I'm not changing anything with the exponents. Here we have negative 4xy plus 1xy, and again, just looking at the numbers, that's negative 4 plus 1, which is really a negative 3, and again, the term just comes down as is, negative 3xy. And then finally, in the last one, we have 3y squared minus 1y squared. That's again, just looking at our terms, 3 minus 1, which is going to give me 2y squared. So the final answer here would be this, 5x squared minus 3xy plus 2y squared. It doesn't really matter the order of it as long as my terms are simplified and expressed as simple as I can get. All right, let's try one last one for an example. This one again has a negative. We're subtracting in this one, so this changes a lot of things here. This is multiplying this second parenthesis by a negative 1. When I do that, remember the signs change in that second parenthesis. So let's rewrite this expression. The first one I'm not going to do anything with, so that's just 7x squared y squared plus 5xy squared minus 2x to the third. Second parenthesis, basically I'm just switching the signs because I have to subtract everything. So that's minus 2x squared y squared. And then here, because it's a negative times another negative, it becomes a positive. So I'm going to put plus x to the third. That's really that expression written out if I'm subtracting the second parenthesis. So from here, let's just look at the terms that I can put together. We'll start with our first term. We have a 7x squared y squared. So again, it has to be exactly the same. If it's an x squared y squared, I'm looking for another x squared y squared. So scanning across it, I come across the second one right here. So let's put those terms together. 7x squared y squared minus 2x squared y squared. Again, it has to be exactly the same. They both have x squareds and y squareds in them, so that's why they're like terms. Let's look at our second one. We have a 5xy squared. So if I scan across, I actually don't have another one. So I'm just going to bring it down as it is and not have to combine it with anything. Now, the last term I have is a negative 2x to the third. And again, I'm looking for another x to the third as a like term to combine it with. And I come across that one right here. And again, remember, that's a 1x to the third. So here we have negative 2x to the third plus 1x to the third. And again, now from here, I can just combine my like terms together and looking at them. So I have 7x squared y squared and minus 2x squared y squared. Again, just focusing on those numbers, that's really 7 minus 2, which is going to give me 5x squared y squared, because again, those terms don't matter, the exponents don't matter, they just come down as is. Because nothing combined with this, let's just bring it straight down. So that's plus 5xy squared. And then finally, let's combine these. We have negative 2x to the third plus 1x to the third. So again, looking at numbers, that's negative 2 plus 1, which is technically a negative 1. You can write the negative 1 or you cannot write the negative 1. It doesn't matter. But that would be negative x to the third, technically. So this final expression written out in its simplified form would be 5x squared y squared plus 5xy squared minus x to the third. So hopefully that gives you an idea, an intro into combining polynomials. We'll look at a lot more and a few more rules as we get into this unit.